Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you out with numbers 27, 29, and 31 in Chapter 8 of your OER textbook. So let's chat about 27. It says, what is the magnitude and direction of an electric field that exerts a 2 times 10 to the minus 5th upward force on a charge of negative 1.75 coulombs? Alright, so what are we given here? We're given a charge of minus 1.75 coulombs. I'm going to draw maybe a picture of that charge. We are also told about a force that's upward. So I'm going to put a force vector in equal to 2 times 10 to the minus 5th newtons. So in order to find the electric field, I would start with this. The definition of the electric field. The electric field magnitude is defined as force over charge. You are given a force, you are given a charge. So that's pretty straightforward calculation. Now you notice it says magnitude and direction. So the problem is vertical, right? The force is vertical. So the electric field, perhaps it's this way, or perhaps it's this way. And then the million-dollar question is which one? Well, remember how the electric field is defined. The electric field direction. It's the force direction on a positive test charge, right? So just keep that in mind when you answer this question. And also remember that electrons and protons always do exactly the opposite. So that should be enough on 27, pretty short problem. Get rid of this and we'll chat about 29. Alright, so number 29, it says, calculate the magnitude of the electric field 2 meters from a point charge of 5 millicoulombs. So we've got a point charge. Value of the charge given in the problem, 5 millicoulomb. I believe that's milli. That M, I believe, is times 10 to the minus 3rd coulombs. And it says to calculate the electric field at a certain distance. Let's see, 2 meters. Now, it doesn't really matter where on this picture. I'll just put the point right here, P. Distance given in the problem, 2 meters. So to calculate the electric field due to a point charge, right, the electric fields are directly proportional to the charge, fall off with distance squared. Where the K is the Coulomb constant, 9 times 10 to the 9th, Newton meter squared per Coulomb squared. The Q given in the problem, the distance given in the problem. So this is a pretty short one. Call that one done. All right, 31. And yeah, they won't all be this short, believe me. In 31, it says calculate the initial acceleration of a proton in a 5 times 10 to the 6 Newton per Coulomb electric field. All right, so we are given an electric field. I'm going to go ahead and write this down. 5 times 10 to the 6 Newton per Coulomb. Now it's 5.00. They're just saying 3 significant figures, so I'm not going to bother writing that. Now I'm going to go ahead and draw an electric field vector. Which way I draw it doesn't really matter. You can draw it any way you want. I'll draw it to the right. Let's assume that this electric field acts to the right. And the question is about a proton placed in the field. So I'm going to go ahead and put a proton here. Proton is a small positively charged particle. Now, some things we're going to need. The charge of a proton is 1.6 times 10 to the minus 19th coulombs. That's the fundamental unit of charge. I believe in this problem you're going to need the mass of a proton as well. I'm going to let you look that up. So look up the mass of the proton. That's going to be some number. And I think what I suggest as you're doing your homework, get yourself a 3x5 card. And put things like the mass of an electron, mass of a proton, charges of both on that 3x5 card. And use it for your homework. And at least in my physics class, you'll be free to use that up until test time. Eventually down the road, though, I'm going to expect that you know the masses and charges of protons and electrons, because those are extremely important. You know, they're the most common particles we'll talk about in this class. But for right now, in the beginning of the class, that's what I would do, get a 3x5 card. What will happen is, after you do enough homework problems, you'll have those memorized in no time. Now, It says to find the acceleration of the proton. So I'm going to start by drawing a free body diagram, which means put force vectors on this. So the Coulomb force, the force created by this electric field acting on this charge, would be this way. And the reason, because the electric field direction is defined as the force direction on a positive charge. And this is the only relevant force here acting in this problem. So now we can write, apply Newton's second law, which says sum of all forces equals mass times acceleration. I would just go ahead and do right positive. There's only one force, equals ma. Now the million-dollar question is, how do we calculate this force? Well, the force is calculated from the electric field. Remember, the electric field is defined as force per unit charge. It's real easy to rearrange this equation. So force is equal to charge times electric field. So the charge is going to be the charge of the proton. Field strength is given in the problem. And then equals mass times acceleration. So that should be enough to get 31 done. That's a short one as well. Hope this video helps you get those rolling. Have a great day.